Hello and welcome to a tutorial by PhysicsMan Education. Today's tutorial will be a tutorial on functions, and we will be deriving the equation of a straight line. I have drawn already here a graph in the xy plane. In case you don't know how this works, there is an x-axis and there is a y-axis. Now, if I put in a point, which I shall call P1, I can describe the location of this point via its xy coordinates. Its x-coordinate, which I will call x1, is a measure of how far along the x-axis this point resides. And then of course its y-coordinate, which I will call y1, is a measure of how far up the y-axis it resides. Therefore I write P1 is equal to the coordinates x1, y1. Now I'm going to draw a second point on the same graph. I'm going to call this point P2 because I'm really creative that way. Now this point will have the coordinates x2, y2. Now, there are an infinite number of ways that we can connect these 2 points via paths that we may take. We can take a curved path, such as this. Oh, my orange marker has decided to not work so well. But we can take a curved path like that. We could take a curved path like this. And in general, we can take an infinite number of different curved paths. We can go extremely high or extremely low, and then back to that point. Of all the paths that we can take to connect these 2 points, though, I assert that the straight line will be unique. Here's why I say that. If I draw a straight line from P1 to P2, and then I try to draw another straight line from P1 to P2, I am simply duplicating the same line over and over. Therefore, 2 points on a graph should be sufficient to completely define this straight line. In order to do this, though, we will need to know how to calculate the slope of that line. The slope is defined as the change in y over the change in x. What that means is, if I were to traverse myself from the first point, P1, to the second point, P2, going from here to here, my y-coordinate will change, and my x-coordinate will change. And then the slope is defined by how much my y-coordinate changes divided by how much my x-coordinate changes. So here's how we're going to express that mathematically. We need to define delta y. Delta y is going to be my change in y. My change in y can also be known as the difference in y. So if I started at y1 and I went to y2, my change will be y2 minus y1. Delta x will mean more or less exactly the same thing, but for the x-coordinate. So, and then just to check that I've written the right thing here, consider delta x as how much my x-coordinate changes. So if I go from here to here, the difference will be x2 minus x1. Therefore, we can write that the slope, and I will quite arbitrarily choose to call the slope m, we can write that our slope m is equal to delta y, the change in y, over delta x, the change in x. Now if we make our substitutions here, where delta y was defined as y2 minus y1, and delta x is x2 minus x1, we can write the full equation that gives us the slope of this line. And that is an equation that we will use again later. Now, at this point, we will consider a third position that will be constrained to this straight line. We will call this position point P. We will not specify the exact coordinates of x and y, but we will mandate that it is constrained to the same line that connects P1 and P2. So if I were to draw this point on the graph, well, I could extend the line over here and draw it down here. I could extend the line up here and draw it up here. It's a little bit easier to draw it between the 2 points. But remember, it doesn't have to be that exact point. I can draw it closer to P1, I can draw it closer to P2, or I could draw it at either extreme. And of course, its coordinates are x and y. So we can write P now. This enables us to find new slopes. We can find the slope of this segment, and we can find the slope of this segment. So for our first segment here, we'll call the slope of that m1. Now, m1 will be the difference between y and y1, because we're moving now from P1 to just the point P. So our difference would be y minus y1. And our difference in x will similarly be x minus x1. At this point, by the way, it should be noted that the order of points doesn't necessarily matter. I could be going from point P to point P1, in which case I would have had to write y1 minus y, x1 minus x. The thing that does matter, absolutely vital, you cannot get this part wrong, xy is a point, x1, y1 is a point. The x is first, the y is first, the y1 is second, the x1 is second. That is because I chose to go from P1 to P. So now if I choose to go from P to P2, I can define the slope of that line segment, M2, which will be the difference here. Now, because I'm going from P to P2, I could go from P2 to P, but I'm going to go from P to P2. I have to put y2 minus y1. Sorry, not y1, just y. I almost made a boo-boo. Similarly with x, I have to put the final x coordinate minus the original x coordinate. But now I have these two arbitrarily defined, but the straight line is a special condition of a curve where the slope does not change throughout the line. It means that the slope of this segment is the same as the slope of this segment is the same as the slope of the entire line. So just write that down. Which enables me to immediately write the following expression. Now, the fact that I have this expression gives me two equations that I can now use. The first equation will come from the fact that m1 is equal to m. Now, m1 up here is defined, and we'll just leave it as equal to m. So, our second equation will come from the fact that m2 also equals m. So we'll use this expression for m2 and we'll set it equal to m. And this will give us our two equations. Equation 1 here and equation 2 there. Let's consider equation 1 for a second. I'll just copy it up here because I plan to manipulate it a little bit. We can go y minus y1 over x minus x1 is equal to the slope. Now, I want to express y as a function of x, which means that if my equation is true, for any value of x along this line I choose, I can plug it into an equation and it will tell me what the value of y at that point is, or how high I need to be in order to be along this line. In order to isolate y here, I'm going to start by multiplying both sides of this equation by our denominator here, x minus x1. Now I'm going to do a couple of things in the same step here. For one, I'll multiply through the brackets by m on this side. Oops, I forgot to multiply x1 by m when I did that. So let's rewrite that a little. But I'm also going to take y1 to the other side. Now if I do that, all that's left here is y. And when y1 comes to the other side, it has to become positive. And this is going to turn out to be one of our important equations. Let's consider this equation number 2. From 2, I have y2 minus y over x2 minus x equals m. And again, I want to isolate for y, this guy here. The steps will be very similar to before. I'll multiply both sides by the denominator, bring y to the other side, so I'll wind up with this negative y isn't very helpful to me because I want y as a function of x, not negative y as a function of x. So I'm going to multiply both sides of this expression by negative 1. Y times negative 1 is just going to give me y. Minus mx times negative 1 will give me mx. mx2 times negative 1 will give me minus mx2. And then, of course, the y2 will become positive. Now, here I have y is equal to mx minus mx1 plus y1. And here I have y is equal to mx minus mx2 plus y2. Both equations have the same form, but they seem very different because here I have x1 and y1, and here I have x2 and y2. My assertion is that if this is true, and we only have one equation that can describe that line, that means that mx minus mx2 plus y has to be equal to mx minus x1 plus y. Mx minus mx1 plus y, yes. So in order for that to happen, this minus mx1 plus y1 has to be equivalent to minus mx2 plus y2. Let's write that down. I almost forgot that negative sign there. Make sure you don't do the same. But because this point here, or this expression here, is defined by this point here, and this expression is defined by this point, the only way that both these sides can be equal to each other is if they are equal to a constant, and we will call that constant b. Calling the constant b is truly quite arbitrary, and it doesn't necessarily prove that it is true. We haven't proven really that this side is equal to that side, therefore equal to a b. I have asserted that. In order to prove it, we will have to rearrange this part of the equation a little bit. So, if we write we'll take all the x's over to one side, so I'll have plus. And I'll do the same thing with the y's. I'll take all the y's over to one side. I'll factor out the m here. And then I'll divide both sides by x2 minus x1. Which gives me exactly the definition of the slope that we had here, which we already know is true. Now that we have shown this line is true, we are free to substitute b in for either minus mx2 plus y2 or for minus mx1 plus y1. Doing either of those will result in the same equation, and that equation is y, when it is expressed as a function of x, is going to equal to m times x, and then I'm going to substitute in b for that. And that, my friends, is truly the most general form of the equation of a straight line. A couple of notes about this equation. This equation has a couple of parameters. Those parameters are m and b. M, we started out with defining m as the slope of the line. Therefore, if you're given an equation like this, m defines the steepness of the line, or the slope of that line. B is not quite as obvious. We'll prove explicitly in another tutorial that b is the y-intercept, but to demonstrate it here, imagine what happens if you take the value x equals 0. Well, if you take the value x equals 0, that will constrain you to the y-axis. If you substitute that into the equation, y defined at 0 is going to equal to m times 0 plus b. M times 0 will be 0, so y, when x is 0, is equal to b. That tells you that when you're on the y-axis where x equals 0, b will give you how high along the axis the line will intersect it, which is why we will call b the y-intercept. To give you an idea of what that means, if I extend the line here so that it goes through the y-axis at this point, that point is at a height b. Or in other words, the point would be x equals 0, y equals b. Thank you for watching our Physics Man Education tutorial. I hope that it has been helpful to you. In future tutorials, we'll offer some more concrete examples of how to use the information that we've learned here. Thank you very much, and see you in the future.